agenda for this session today. We will start with an overview of API management, then briefly discuss about the platform versions, deprecation notice, followed by the mechanics of the migration, and go into an in-depth walkthrough of the various migration scenarios that you might encounter. To start with an overview of Azure API Management. API Management is a PaaS service which abstracts a lot of infrastructure components from the consumers. The physical separation is something what we see when we interact with the portal. So API management is addressing the most complex API exposure that organizations usually want to accomplish. Now there are different personas that API management interacts with. It has the developers who are the API providers who interacts continuously with the management plane using a variety of tools. They go through the complete life cycle of the API management development. Then once the APIs are available for consumption, the app developers are the ones who interact with the developer portal of API management and then go about discovering them, trying them, and then including them in their applications. Once they include these APIs in their applications, the customers or the users of the actual applications invoke the APIs through their applications. This persona interacts with the gateway component of the API management, which routes your requests appropriately to the backends in a more secure way. Now, different personas interact with different aspects of API management. This is what we see at a high level from the portal, but these are all the logical components of API management. From a physical perspective, API management consists of two main architectural components. There is the compute platform where all these logical components run, and there is a storage layer where the metadata is persisted. Now, when we go about asking what this retirement is about, the retirement is about the compute platform version STV1 being retired effective 31st August 2024. So as a cloud platform, the Azure API management abstracts, as I said, many details of the infrastructure used to host and run your service. The infrastructure associated with the API management STV1 platform version will be retired. Now, how do we know what are all the dependent components? So if we go to our Azure portal and look at the network tab of an API management instance, the status here tells us what are the different infrastructure components that the API management instance is interacting with. You can predominantly see SQL database, table storage, queue, blob storage, which are part of the Azure storage. So all these are where the metadata is hosted for this particular API management instance. Now, what we are doing as a part of this retirement is just upgrading the API management compute platform version. So the compute platform version, which is STV1, is getting migrated to a more resilient STV2 platform. So the underlying metadata or the storage layer is not getting affected, and it's just that the compute platform which is getting migrated to a more reliable and resilient option. From a from a continued support to take advantage, right, to take advantage of the upcoming features, it is important for all the customers to make sure that they migrate their API management instances from STV1 compute platform to the STV2 compute platform. So the STV2 compute platform is Azure allocated compute as well, but with added resiliency and security features. It'll have all the upcoming new features. And the STV1 platform, as you might have observed, you don't have the resiliency features like availability zones in there or the advanced networking features. So that's what we are looking at, where all our STV1 instances should be migrated to the latest STV2 platform by August 2024. How do I know what is the current platform version I'm on, right? Just head over to your Azure portal, go to the overview and look at the platform version under the overview. If the platform version reads STV1, then you are expected to migrate this at the earliest possible, because once we reach August 2024, all your API management instances will be shut down and your APIs will stop responding. So it is important for you to make sure that all these instances are upgraded to the latest STV2 platform at the earliest. So what happens during the migration, right? We said we said that we're just migrating the compute platform there, right? We're not doing any modifications to the storage layer or where the metadata is stored. So during the migration process, uh, the what we are doing is we're creating a new compute in parallel to the old compute. So we're not touching any of the metadata there. It's just that the compute is parallelly getting created, and both the old compute and the new compute will coexist for a configurable duration. We'll talk about that a little later. Now, once the process starts, once the upgradation process starts, the API management status in the portal will read updating. So the moment you see it is updating, it means that your migration process has started. And there might be scenarios where you might have downtime or you might not have downtime, depending on which option you have selected and which configuration that your API management is currently being used. So once the migration is completed, Azure automatically updates the management endpoint of the API management, right? So this makes that the compute immediately that the compute once it's successfully migrated, the migration process will automatically update the management endpoint to the new public IP that you would be providing. We'll talk about it a little later. Now, because the old and the new compute coexist, there are cases if you are using a custom DNS or a custom domain or a reverse proxy, the gateway DNS still points to the old compute. That means that the new compute is created, but it is not actively receiving the traffic. So this facilitates a lot of use cases like validating the new compute before cutting over from the old compute and so on. Now, it's because it's just the DNS, as I said, which points to either the new compute or the old compute. We have a variety of scenarios that pops up, like will there be a downtime or not? How if I can validate my APIs before doing the switchover or not? So you have absolute control on when you wanted to fail over if you are using custom domains, reverse proxies, or custom DNS. Now, there might be some dependencies which the upstream and the downstream systems might have taken. It might be routed through a firewall. You might need to update your firewall rules, the NSGs, the networking components, and so on. So it's critical. It's very critical for us to review the networking dependencies and make sure that they're all updated upfront to ensure a smooth migration. Now, what options do I have? The answer is it depends. It depends on the networking model of API management you are currently using. As you might have known, API management offers three network models. It offers a none model, which is saying that this API management instance is not integrated into any virtual network. That's the simplest of the scenarios. Now, there can be other two options which are integrated into a virtual network, one which is exposed publicly and one which is completely cut off from the public internet. Now, the external instance is where the API management is integrated into a virtual network for access to private backends or to backends on premises. But the API management is directly accessible to users and administrators through a public IP. So that's what an external API management instance is about. Contrary to this, the internal API management is still integrated into a virtual network for all private backend accesses, but it is not publicly available for API consumption for users, but it is still accessible by administrators for administrative tasks. So the fundamental difference between the external configuration and the internal configuration is that both are integrated into the virtual network, but one is publicly exposed for API consumption, whereas the other is not publicly exposed. Let's look at some detailed scenarios on how we can migrate each of these networking models. Let's start with the non-VNet injected instances. I'll have my colleague Andre talking you in depth about how to migrate your non-VNet injected instances.
Really? Um, okay, so the first scenario here, if you have API management instance that's not injected into a virtual network, how we do the migration? So the first question is, let's recap what Sweeney just showed here, how we can see if your API management instance is not or is injected in a virtual network in Azure. So the first thing you can check here, if you only have the public IP address here, that's one way to see, okay, there's no private IP address listed here. That means you're running not injected a virtual network. And the other way is also, as Srini showed here, you can go to the network menu and you can just verify that your virtual network is set to none here. And is there any other, if I have multiple instances here, is there a way to check among my subscriptions how many instances I have that need to be migrated and so on? And my recommendation in this case is that you go to the Azure Advisor. And then if you go to Reliability Blade here, and you should have this warning in high impact migrate API management service to STV2 platform. And here you can see all your instances that need to be migrated instead of going one by one in this case. Okay. All right. So let's see what else do we have here. So we have in the official API management documentation all the steps required for this migration. The same thing I'm going through by this video. Okay. But let's take a more practical approach. Let's go directly to the portal and I can show you there how to begin the migration from there. But just for your information, you have the portal way to do these things. We also have the Azure CLI as the steps here if you prefer. For this video, gonna be using the portal. All right. So let me go back to the portal. And then here my APIM instance, as you can see, it is STV1, the platform version. That means I need to migrate before August next year. And then if I go to the platform migration blade, yeah, I'm presenting the same information that I have in the documentation there, what options do I have to migrate my instance that's not injected in a virtual network? So basically we have two major options here. One, I can migrate to a new virtual IP address, which is a recommended approach from Microsoft, or we can run the migration preserving the IP address for my API management instance. So what are the major difference between them? The first recommended approach here to assign a new virtual IP address. That means you're not going to have any downtime during the migration. That means after the migration process is done, your request gonna be your new APIM instance gonna be online, and that means the transition happens without any downtime for your users. Okay. The only thing here that since your APIM is gonna be getting a new IP address, that means you need to update your external network dependencies such as DNS servers, custom domains, certificates, and so on. Okay. Uh, so that means all these management operations on the infrastructure level that I mentioned here is going to be locked during this process for around 30 minutes during the migration period. But then in the end, we have no downtime. And another thing that's good to mention here that you are able to test your old gateway instance and the new one in parallel. Since you're getting a new IP address, the old running instance gonna be still be there for up to 2 days, 48 hours. So you're able to validate your older instance with the new one in parallel. The second option here that you have, you can migrate this instance preserving the IP address. That means in the end of the migration, your public IP address will not change. However, uh, in return, that means you're going to be getting 15 minutes of downtime during the migration. So yeah, nothing changes regarding your DNS servers and so on, because you're going to be reusing the same IP address as the previous instance, the STV1, but in return, you're going to have some downtime during this migration. And then again, the same infrastructure configuration, like locations, regions, custom domains, and certificates, gonna be locked for 45 minutes using this option. So that's something to keep in mind, okay? So you see, the option that's select here, either using new virtual IP address and preserving the IP address, uh, we have some steps here to review before the migration, during the migration, and after the migration. And they change depending on the option that you select here. Okay, so let's start to see what did you check before the migration. And we have 3 steps, and they are the same for both scenarios here, either new virtual IP address or preserving the IP address. So the first thing here to be aware, what are the external dependencies to my APIM instance? Do I have like DNS servers pointing to them? Do I have firewalls and all these things that might be impacted by the IP change, or not the IP change, right? But the downtime if I'm preserving the IP address in this case. So good to have in mind what can be the external impact of the IP change, for example, for the migration. Another thing here that we recommend to back up the service configuration, because the migration is supposed to go smoothly, no problems there, and automatic rollbacks in process too, they're going to be mentioning. But it's always a good practice to back up your instance. And for the API management, we have entire documentation how you can back up your instance for restore later. So it's always a good practice to have the backup before anything else. And of course, you need to plan for downtime. Even if you're not having any downtime in here directly, but anything that might happen because of the process and so on. So do this in the non-busy hours for your clients. And then what happens during the migration? Then here things change a little bit, because if I'm migrating using a new IP address, what will happen that, as Renee mentioned, a new additional instance will be provisioned behind the scenes by Azure in parallel with a new public IP address. And then, as I mentioned, any configuration related to infrastructure will not be allowed during that time. And then, during the migration, you should expect some downtime there, depending on the option that you chose here. No downtime for the new virtual IP address, and then some downtime around 15 minutes for the preserving IP address option here. Okay, and after the migration, so if you chose to a new IP address, then as I mentioned at the beginning here, you should check for any external network dependencies. Let's say a DNS server pointing to the old APIM IP address should now be pointing to the new one, and so on. But here's something good about choosing a new IP address, because if your DNS server is still pointing to the old APIM IP address, it will be keep responding normally, for up to 48 hours or 2 days. So you're still able to validate the new deployment to the new IP address using the built-in domain name, for instance, while the previous STV1 instance will be there running and responding to requests while you don't do the update on the DNS server in this case. So you can do this parallel validation after the migration. The same thing will not happen if you choose to preserve the IP address, because obviously, the gateway IP address will be replaced by the new instance instead. So you cannot do this validation side by side, let's say. So that's the downside. Even though, in the other hand, you don't need to update any external DNS servers or things like this, since the IP address is exactly the same after the migration. So one thing that we didn't mention about here, what happens if there is a failure in the process? For example, let's say that I click migrate here, and then something goes wrong behind the scenes on the migration. What should I expect in this case? So there is two things. There are things here to keep in mind. First one, after we click to migrate here, the status of your instance will be updating. And then if it still shows updating after 2 hours, it's probably something went wrong there. And then it's a good idea to open a support ticket. And we have instruction for this on the official APIM migration document here in the end, how to open a support ticket for this scenario. But normally that's not what's gonna happen. In case of failures, there's automatic rollback process happening behind the scenes. That means your status will be like from updating back to online, but the platform version will still be showing STV1 and not STV2 or 2.1. That means the automatic rollback kick it in, and you can try to migrate again. But after multiple failures and automatic rollbacks happening, it's always a good idea to call the Azure support and try to get some help from there in this case. Okay, but then after the migration, we should see status online and then platform version STV2 or STV2.1. That should be your success indicator after the migration. So let's try to do the migration now and see how it looks like. So let's try to perform the migration again. And here I am. I just check the box here. So I understand the impact migration process after reviewing all the before, during, and the after migration steps here. And let's do the migration. Let's see what happens. Okay, so the migration process started. And the way that I know it's ongoing, if I go back to the main status of my instance, it should be reflecting, updating here when I refresh it. Yep, so it's updating, and the platform version is still STV1. Okay, so it's happening. So this should take some time, between 30 to 45 minutes normally. But I have another instance here that I migrated before this video, showing how it should look like after a successful migration. So here, and that's how it should look like. So it says status show online and platform version STV 2.1. So migration was a success in this case. So that's it. Then since I choose a new IP address for this instance, I should now be checking the external network dependencies, DNS and firewalls and so on, just to see if my new IP address here is causing any impact on the external dependencies. And I think that's it for the non-VNet injected scenario. Back to you, Srini.
Thanks, Andre. Now that we have looked at how we can migrate a non-VNet injected instance from STV1 to STV2, let's move on to looking at how we can migrate a VNet injected instance from STV1 to platform version STV2. Like we said earlier, there are two kinds of VNet injected instances, the external VNet injected instances and internal VNet injected instances. The fundamental difference between both the instances is how the gateway is exposed publicly. In external injected instance, the gateway is publicly exposed, whereas the internal instance, it is completely private. But in both the cases, they are injected into your virtual network to access your private backends and on-premise backends. So since these are injected into a VNet, To migrate a unit injected instance from STV1 to STV2, we have certain requirements. We need them to be migrated to a newer subnet with a newer managed public IP address. Now, both external and internal instances requires a public IP address in the earlier STV1 platform as well as the newer platform. The difference is in the earlier platform, these public IP addresses are Azure managed public IP addresses, but in the newer STV2 platform, we expect these to be customer managed public IP addresses and be provided for each migration that into the newer subnet. So we need a newer subnet with all the network dependencies addressed for that particular instance, as well as we need a new customer managed public IP address. Apart from that, there are certain NSG rules which are needed for the operation of an API management instance. It's the same set of rules that are applicable for an STV2, STV1 instance, but in STV2 we have a couple of additional rules, which is an addition on top of what we have for STV1. Similarly, if you are operating with an UDR or a firewall, we need to make sure that these are updated for the newer subnet address spaces as well to make sure that the communication to all the dependencies is possible from the newer subnet as well. Now, we talked about the customer managed public IP address. You might ask, why do I need a public IP address for internal instance? This is not something new because even the STV1 internal instance has a public IP address for management plane access. If you look at the diagram here, we have the gateway and the developer portal components available over a private IP, which can be further exposed publicly using an application gateway. But for management operations, if you have to reach out to the management plane through your Azure portal or SDKs or CLI or infrastructure as code components or scripts, you want that to be publicly available. So that's where the public IP comes handy, which allows access to the API management plane, but in a more secure way. Rest assured, this particular public IP address is used only for administrative activities and it is secured by a certificate. So only the management traffic is allowed on this public IP and not any other API traffic is allowed on this public IP. So it is required for you to provide a customer managed public IP for both an external instance as well as an internal instance. Going back to looking at what these NSG requirements, as we spoke a bit earlier, the STV2 NSG requirements are kind of an addition to what we have in STV1. In STV1, you could compare it to have the same set of rules, except the highlighted ones where there is an Azure load balancer rule, which is updated to be on a specific port, whereas in the STV1 it is on all ports. And we also have an additional NSG rule for an added dependency in Azure Key Vault. STV2 depends on Azure Key Vault, so we are needed to provide a newer addition to the NSG for access to Azure Key Vault. Now you can either update the existing NSG to these to add these rules and reuse the same NSG, or you can provide a new NSG with all these rules. That way you are not changing or updating the older NSGs to meet the STV2 migration requirements. Like NSGs, you might want to force tunnel all your egress traffic from your API management instance through a corporate firewall. So if you're doing that, even in the STV1 instance, we rely on service endpoints for all dependency traffic to be bypassed from the firewall and go through the Azure backbone. So that's where the service endpoints comes into play. Now, this requirement is the same as STV1, but with an additional requirement for Azure Key Vault, which is an additional dependency for STV2. So we need to make sure that all the service endpoints are configured on the subnet to just make sure that the dependency traffic is allowed. And if you are using a firewall and a UDR to route all your traffic to avoid asymmetric routing for your management plane traffic, you need to make sure that the API management service tag is set to the next hop as internet. That way, there is no asymmetric routing issue, and the traffic flows through for all management related operations. Last but not the least, these firewalls might have been configured for service dependencies at the firewall. The firewall might be blocking certain traffic, which is not governed by the service endpoints. Not every dependency traffic is taken care of by the service endpoints. For example, metrics, diagnostics. These are some endpoints which are not taken care of the service endpoints, and they still need to be allowed at the firewall level to make sure that the traffic flows from your API management instance to the dependencies. That way, they're all taken care of for a healthy API management instance. Now that we understand what the prerequisites are, how to take care of the dependencies, let's look at how I can migrate an API management instance. So to migrate an API management instance, you just have to simply go to the network tab and click on the location that is available for that particular for that particular region, and configure the newer subnet. It could be either a new VNet or a new subnet in the same VNet. Just configure the newer subnets which meets all the networking requirements and associate the newly created public IP. Please make a note that if you don't specify the public IP address, your instance will not migrate to a STV2, and it will still stay within the same STV1. So it is very important for you to make sure that you provide this public IP address to ensure that your instance platform version migrates from STV1 to STV2. There is an alternative way to achieve the same migration through the locations feature, right? If you are on the locations feature, you can click on the one of the locations that you might have and change the availability zones at the same time while you are upgrading the instance as well. So you still have to provide the new network, and you still have to provide a new virtual new virtual IP address that is required for the platform version migration. But you can also update the zonal the availability zone support for your API management instance. If you are not using it in STV1 because that's not supported, if you want to make sure that you take care of both of them in a single shot, you can as well come here and update the availability zones and convert the platform version from STV1 to STV2 in a single attempt. Now, before you start the migration, like what Andrew said a while ago, it's always important for you to back up your API management instance for any eventuality. It's a good practice to make sure that you back it up, and you can either back it up through the PowerShell or through the REST API. If you're trying to use the PowerShell, provision a storage account and use the backup AZ API management PowerShell commandlet, and ensure that you take a backup of the instance before attempting any migration or any service level changes. Not just for migration, but if you are attempting to do any kind of service level changes, make sure that you back it up to ensure that you have a fallback if you ever require. Uh, and also make sure before you start migrating it, you make sure that you validate the new subnet that was created. You might have done a couple of NSG changes, service endpoint changes, or UDR firewall changes, but you need to make sure that you have an eyeball on it, and then go ahead and verify that all these configurations are in place before attempting a migration. Otherwise, the migration would fail. Optionally, you can also create an API management instance within that new subnet and wait for it to come online. Look at the network status and see, make sure that everything is green in there. It's kind of ascertaining that all these network dependencies are taken care of. Once you have the API management online, you can delete the instance, clean the subnet, and reuse that for the migration purpose. This way, you are doubly sure that your API management deployment will succeed. Now, once you start the migration, we've talked about at the beginning that once you start the migration, the instance status goes into an updating state. Now, what happens behind the scenes is we provision a newer compute with the STV2 platform version parallelly to your older compute. So when you attempt the migration, if API management would would create a newer compute on STV2 within the subnet that you have provided and with the public IP address that you have provided to it. But still note that the pointer, the DNS entry will still be pointing to the older compute if you are using custom domains. The default domains will obviously get updated on the fly, but if you're using custom domains and if the customers are using the old instance, will still be taking live traffic. So this gives us an opportunity to validate your newer compute, test it through localization techniques, and once you are satisfied with the changes, you can flip the switch and say that point the DNS entries to my newer compute. And once you do that, you can let go the older compute and let it purge. In all these scenarios, please note that your metadata is not getting changed. So the underlying storage layer is not getting affected and all your data is safe. When we talked about this, right, we talked about the old gateway and new gateway coexisting, but we also have to make a note of what is the benefit of them coexisting. The benefit is zero downtime, right? So there is no real downtime to your live API traffic because your old gateway will continue serving the traffic throughout this process, and your newer gateway is available for localized testing. And once you decide that the newer gateway is good to go, you will flip the switch and point the custom DNS entries to the newer gateway to complete the migration. So the old gateway continues to serve the live traffic throughout the migration. The only caveat is that infrastructure configuration, such as custom domains, locations, and certificates, this will be logged for a period of 30 minutes during the migration process. That way, we don't want that to interfere in any of this migration process. Now, there's a subtle difference between using custom DNS and default DNS. As I mentioned here, once we provision the newer gateway, all the default DNS entries will be updated to point to the newer gateway. If at all you are using the default DNS, or if you're using custom DNS, which is CNAMEd to the default DNS, the switch to the newer gateway is immediate and it will start taking traffic, and you might not have the ability to validate it. But this gives you an ability to roll back if at all it is required to go back to this older instance. So in one instance, it gives you the provision to validate. In the other, it gives you a benefit of rollback, or it gives you both the options. So that's the beauty of this particular parallel migration strategy. So if you're using custom domains, check if you're using an A record or a CNAME, because that decides whether your new gateway will start taking traffic immediately, or it will wait for you to flip the switch and tell you when you are ready to migrate. So we've talked about downtime, and we could also talk about the validation, right? This is the advantage we talked that the parallel deployment will bring, because if you're using a custom domain, or if you're using a reverse proxy, or if you're using custom DNS, this will all be pointing to the IP address of the gateway. So if they are pointing the IP address of the old gateway, now you have the ability to validate the new gateway in a more localized way. You can update the host file to point to the newer gateway, test your changes, and then go about validating it for all the dependencies. So if at all there are any network glitches, you have a chance to fix those network glitches because they coexist for a configurable amount of time. Make sure that you request for the time that you want both the instances to coexist before you make your deployment. The old gateway, all throughout the process, continues to serve live traffic without any hiccups. So you have all the ability to go and validate the newer gateway and keep updating the network glitches as you notice, and make it available for that to be a switch. Once you are completely satisfied with your localized testing, you just update your DNS, reverse proxies, or custom domain entries to make sure that they point to the new gateway, and the new gateway starts receiving the traffic automatically. Now, in this particular process, right, if you have taken care of migrating, if there is a successful migration, uh, how you go back and check is the status should read online, and you should see the platform version as STV2 or STV2.1. And you can also note that the virtual IP address will now change to the IP address that you have provided during the migration. Now, if you have an external instance, you'll just have one public IP address. But if you have an internal instance, you'll have one public IP address for the management traffic and a private IP address for all the gateway traffic. So if at all you haven't you haven't successfully migrated, right, you have to look at what failures look like and how the failures are handled in this whole migration process. So there are two cases where your migration can fail, right? If Azure fails to provision the newer compute, or if Azure successfully provisions newer compute, but the APIs are all failing because of upstream or downstream network dependencies. So in either case, if it is failure during the provision of the new compute, that means the new compute never got created. So API management will automatically fail over to the older instance. So you can see that through the status. If the status becomes online, and if the platform version did not change to STV2 and it's still STV1, then it means that there is an automatic failover that happened because it couldn't provision the compute. You can either retry it, or you can reach out to support to understand what is the exact reason for the failure, fix it, and try to attempt the migration again. But on the contrary, if the migration is successful, if the new gateway and the old gateway are coexisting, but your APIs are started failing because your default DNS have switched the DNS entries to point to the newer gateways, but there are some downstream network dependencies which are blocking your request from the newer subnet to the backends. So there could all be possibilities. Either you can attempt to fix them and try to bring it online. But if you are time crunched, and if you want to make sure that you want to roll back the instance, you can always reach out to support and ask them to point the DNS back to the old gateway. But make sure that you need to raise the request and reach out to the support in time before the old gateway gets purged. So it is very important for you to raise a request upfront to ask for the time that you want the old gateway and new gateway to coexist, and keep that in mind while you request for a rollback, because only if the old gateway exists, you have an opportunity to roll it back to the previous state. Now, we talked about the second scenario on the rollback, where there could be network dependencies which could make the APIs fail. So what are these network dependencies? The network dependencies can be an upstream network dependency, where they have taken a dependency on the public IP. They are allow listing traffic to that IP. Now that the newer IP is changed, so they might be experiencing trouble, or they might be experiencing downtime. So you, you at this point of time, it is important for you to realize them upfront. So this is something which you know beforehand, that your public IP changes. So you need to make sure that you reach out to the upstream parties and have them update their dependencies beforehand. That way there is continuous access to the backend once the DNS are flipped. But unfortunately, there is no real way to retain or reclaim the existing public IP address. So you definitely have to look for a newer public IP address and request your upstreams to update their dependencies for a continuous for a continuous flow of traffic. Similarly, the downstream could also take dependencies, right? There can be application or reverse proxies which have taken dependencies on the outbound NSG rules for the subnet of API management, or something like a backend app service residing in its own own subnet might have an inbound NSG rule which says that allow only traffic for this from this particular API management subnet. Because the newer subnet address space is changed, there is a possibility that if they are not updated, the traffic might get blocked and your APIs might start failing. The same goes with firewall. If your traffic is routed through the firewall might block those traffic because it is still looking for traffic originating from the older subnet, but all the new traffic is originating from the newer subnet. So it's important to identify these dependencies upfront and update them even before you attempt the migration, because all this can be done upfront. Bearing the reverse proxy updates, right? The DNS and the reverse proxy updates, which you can update only after you validate it and you decide to flip the switch. Until then, you can always update all the other network dependencies and make sure that you are ready the moment you decide that your application new instance is live and it's validated, you should be in a position to flip the switch and do a seamless migration from your old gateway to the newer gateway. Now, there might be scenarios where it is very difficult for you to identify all the dependencies on the older subnet. So, if it is a challenge, then you can definitely move your instance back to your older subnet, but it can't be done in a single pass. It has to be done through multiple passes. So, for each of the pass, you need to provide a newer subnet and a newer public IP address. So, in this case, if I have decided to move this API management instance from this virtual network to a different subnet or different virtual network, I need to provide a new subnet and a new public IP address. So it gets created parallelly. So if once it's created, the pointer moves back to the newer instance. At this point of time, this is when your downtime starts because the newer subnet is not configured for all the network dependencies. So this is where your applications, your consumers start noticing downtime of use because your routing will fail. Now, at this point of time, you will have to wait for the older subnet to be vacated for you to move this new compute to the older subnet. So this is the time where you'll have to request support to configure upfront as to how much time you want this compute to coexist. So if you want that to be exited immediately, you can select any time between 15 minutes to 48 hours, and you can raise a support ticket upfront saying that, hey, I am upgrading my API management instance. So please configure my older subnet release to X number of minutes. Now, once that subnet is released, then you can attempt to migrate this compute to the older subnet again. Now, make note that you have the subnet, but you should again provide a new public IP because you are moving from this compute version to the newer subnet. So you need to provide a newer subnet, customer managed public IP address. Once you provide that and you take the same steps of going back to the network tab and updating the subnet and the new IP, then this compute moves back to the older subnet with all the dependencies. And this is when your traffic, your newer compute on the old subnet starts taking traffic. And because it has all the network dependencies intact, it will be able to continuously serve the traffic from at that point of time. But please note that if you are deleting the older compute instance, you are losing the ability to roll back, right? Because unless you vacate that, you can't move that instance back to the to the older subnet. But if you are deleting it, from the moment you delete it, you are forfeiting your right to to roll back for any instance because your old instance is deleted and there is no way that you can roll back to that state at any point of time. We have talked about moving back to the older subnet just to avoid some network configurations to be done. But unfortunately, we have to take a downtime because the old subnet has to be vacated before moving the STV2 gateway back to the older subnet. But we can avoid that downtime through multi-region instances. So if your API management instance is configured for multi-region, you can achieve zero downtime upgrade even if you are switching back to the older subnet. But make a note that you need to do the migration at one region at a time. You'll have to disable one gateway, attempt migration on that particular gateway, and move back to the other gateway, bringing the old one back online and disabling the newer one. Now, whenever you migrate at each location, you need to provide a new public IP, and also you need to have a subnet for each of the regions. So how you go about doing it is disable that gateway. Either you can disable that or you can just configure that at the DNS level or the reverse proxy level. So to cut traffic to the gateway that you are planning to migrate, and then attempt migration on that particular gateway and go back and do it on the secondary gateway. In this whole process, make sure that the gateway which is which you can avoid the downtime at, because the developer portal is only available in the primary region. And if you're cutting traffic to the primary region, your developer portal will have to take a downtime irrespective of how you migrate it. So multi-regions comes handy in terms of doing migrating back to the older subnet, but with a little or no downtime to your actual instance. And this is how you look at, right? If you're talking about the primary region and the secondary region, the primary region has the developer portal management plane and the gateway, whereas the secondary region just has the gateway. So if you are cutting the traffic at the DNS level, say if you have a custom domain where you have CNAMED it to the default domain, make sure that you don't default to the you don't CNAME to the default domain. Rather, you point the custom domain directly to the region of your choice and attempt the migration on the primary region first. And during this period, only the gateway will be available on the secondary region taking live traffic, whereas the developer portal and the management plane will be down for that specified period. And during this period, you attempt the migration, you can move back to the original subnet, or you can just keep it the same. And once you are successful on that, update your custom domain again to point to the primary region, thereby disabling the secondary region and running the migration on it. So definitely using multi-region instances, you'll be able to achieve a much better migration experience with no downtime to the gateway component and little downtime to the developer portal components. Now, there can be cases where changing the existing API management is a strict no-go for some deployments. So if you are into that boat, you can always look at side-by-side deployments, but note that replicating an API management instance is very complex. You have to take backup, and not everything is included in the backup. So you have to make sure that all the configurations are captured as infrastructure as code so that you can replay it on the newer instance and ensure that all of them all the instance will be alike. The backup will definitely contain the subscription IDs and the user ID components, but it doesn't contain the developer portal component. So you may have to do multiple automation efforts to migrate different components of API management. Though it takes a little more time, it is a safer approach when you have a policy not to modify the existing instance for whatever reasons you might have. We have a detailed blog on a guide to creating a copy of an API management instance, which talks about what are all those what are all those configurations which are not included in the default backup, and how you can mitigate them, either some of them through taking a dump of the analytic reports, or some of them through infrastructure as code, where you configure these settings in your infrastructure as code. That way you can replay them appropriately. There might be additional considerations in terms of downstream dependencies and things like that. So just make sure that you understand how you have configured your API management and ensure that everything is captured in detail. That way, your newer API management instance is an exact replica of your older instance for you to act as a backup. In any of the scenarios above, if you think that you need more information, feel free to ask for help. You might have to reach out to support in multiple scenarios. One, if you are a customer who wants to have a faster vacate time for your older subnet, or if you want your old compute to coexist for a longer period of time. In either of the cases, it's always advisable to reach out to support and ask to configure your particular instance for the desired time of coexistence. Now, there might also be scenarios where you might decide to roll back your migration to the older gateway. You can as well reach out to support in time to ensure that your old gateway is retained and the configuration is rolled back. But please note that you will have to reach out to the support well ahead to make sure that your rollback is initiated before the older gateway is purged. So that's very important. In case you have any other questions, you can always reach out to your account team or the Fast Track for Azure team for any help. We also have certain resources to go over the migration activities. And we have the retirement announcement, which details about what is this retirement about, what are we going to do and how we go about in the dates. And we also have an migration overview blog, which was authored by us, the which details on the various aspects, various scenarios, the pros and cons. And there's a detailed FAQ included in our migration guide, which outlines all those topics that we discussed in this video, as well as a migration guide in detailing this certain scenarios of both non-VNet injected and VNet injected instances. There is also a blog on side-by-side deployments about what you need to care for whenever you are deploying API management. Now, this is the STV1 platform retirement announcement we are talking about. You can always reach out to this page and understand what this retirement is about, when is it getting retired, and the mechanics of this whole migration. And the migration block, which is what we're talking about in detail on how to migrate it, a flow chart indicating what is the path that you may want to take, and the pros and cons of the various options of non-VNet injected instances migration as well as VNet injected instances migrations. And the FAQ here is what we are talking about, all the details that are required to decide on the migration path that you wanted to take. It has a good set of questions curated with detailed explanation for each of the questions that you might have. Followed by that, we also have a migration guide, which talks about the different options available, what happens during the migration, what are the steps. Though the steps are not uh, too much here, but there's a lot of conceptual understanding that is required for you to decide the right migration path and initiate the migration in the way that you expected it to be. And lastly, the blog, which is about creating a copy for side-by-side deployments. This might not be very specific to migration, but at least it gives you an outline about what are all the different gotchas that you need to take care of whenever you're trying to create a copy of your API management instance. So make use of these resources to facilitate the migration activity from STV1 to STV2. To summarize, we've talked about the STV1 to STV2 migration process, the mechanics involved, how the migration happens, and what are all the things that you need to look out for. And we also talked about how we migrate non-VNet injected instances, VNet injected external instances, and internal instances, the nuances, what the subtle differences between them. Also, we talked about migration strategies that should be applied in each of these cases, where you have some downtime, where you don't have some downtime, maybe the multi-geo migration scenarios, or the special cases like a side-by-side deployment strategy as well. In all these, we have been focusing much on what is the downtime, how does it impact your business, how can you validate before initiating the migration, as well as how can you validate the migration after the migration has taken place, and last but not least, what can you do to roll back in case of an eventual failure. So this information should help you carry out your migration from API management STV1 to platform version STV2. Thank you for watching this video.